Chapter 1, let's talk about what operating systems are. We're going to be talking about the purpose and function, events and the evolution. The textbook goes into just unbelievable detail about the history of operating systems. We're not going to go quite that in depth, but we're going to talk a little bit about how they've evolved. Some of the different desktop OSs we're going to talk about during the course of this class, and then mobile OSs and things associated with those. So an operating system is a collection of programs that control the interaction between hardware and software on a machine. The interpreter between the user and the hardware. So computers speak in ones and zeros, right? We don't speak in ones and zeros because we're not computers, at least not yet. I watch a lot of sci-fi, you'll have to excuse me. But the operating system is the thing that's supposed to be that interface between us and the hardware of the computer. So, an application allows a user to perform some sort of function. Applications send commands to the operating system so that then the operating system can interact with the hardware. So that could be like a word processor, a spreadsheet, a database, something that edits or creates graphics. Some of the hardware components we'll come across, we'll hear the word computer. That's just a device that performs calculations. That could literally be anything. It's not just the tower that we see sitting down by our feet today. We've also got the central processing unit, or the CPU. That's the thing that actually does the processing and the calculations for the computer. A microcomputer is a computer that's really small, it's really cheap, and generally one person uses it. Kind of a weird term since we all kind of have computers in our pockets with our cell phones now, but that is a term that the textbook does use. A microprocessor is just a cheap, small processor. And then we have the integrated circuit. So the integrated circuit is a small electronic component made of transistors, very, very miniaturized little parts that have led to the decreased size of computers. So as the integrated circuit has evolved, the size of our computers has become smaller and smaller, and their processing power has become more and more. So used to, we had mainframes, right? We had the ENIAC before, if any of you even know what the ENIAC is. So it's a computer that was the size of a house or a room. So you had to use punch cards to build your programs, and they did very, very simple arithmetic calculations, and that's pretty much it. So this is the computer of, let's say, the 60s. Now the integrated circuit was actually invented in Dallas by a guy named Jack Kilby at Texas Instruments. So the integrated circuit is actually from Texas, which I always thought was kind of cool. Input is sending something into the computer, like a keystroke on a keyboard or a click of a mouse. The output is whatever the processed information is. So that could be something that appears on a monitor, something that gets printed on a printer. RAM is the random access memory, is the main memory for holding programs and holding data that need to have something done to them. And then when the computer turns off, that goes away. So it's like a temporary storage. It's only used when it's needed. Firmware, we'll hear that term a lot. That's the software that's installed inside the circuitry of the computer. It's still there when the computer turns off, but it's supposed to teach the hardware and the operating system how to talk to each other. So there's lots of different components that happen between us using a computer and it actually doing something. Lots of different things at play. There's a motherboard, which is the point of connection for everything inside the computer. Does anybody know why it's called a motherboard? No?
That's why we're in here.
Okay. So originally there was a motherboard and there was a daughter board. And you plug the daughter board into the motherboard, and you plugged other things into the daughter board. Well, eventually all of it just became one big piece, and they just kept the name motherboard. So it actually has some meaning behind it. It's not just a weird word. Some more hardware components that we'll find. The ROM BIOS. So have any people who game in here, Shirley? Right? Have you ever overclocked?
No.
No? What?
Yes,
you have.
I won't overtop my stuff. It's shortage your night of your.
Okay,
I'm like, you
see,
have to be concerned.
that's such a good answer, but okay. If you've ever overclocked a processor before, that you know that one of the places you go to do that is the BIOS. And some BIOSes have that capability built in, or to let you overclock it just a teeny tiny bit, just so you kind of have that high of doing it. But that is the kind of thing that we're talking about when we talk about the BIOS. So originally we had ROM BIOS, which was this like ancient screen that popped up, and there was like 3 of them. I don't know how long I've had a computer, but I've had one since I was 4. So I've kind of seen the evolution of these things just a teeny bit. So now the ROM BIOS has been replaced with what we call UEFI. We'll talk more about that in detail and why we need it later on. But a device driver gets installed in the OS to tell the system how to use that component. And if I install a graphics card and I don't install a driver, then the computer has no idea what it's supposed to do with this. It might even be able to tell that it's a graphics card, but it can't really tell what it can do, much less, you know, if I can do crossfire, sly, or something like that. It can't tell that without the right driver. So that's one of the reasons that we use the BIOS. So today's computers, we have the desktop. That's generally designed to stay in one place. It's not meant to be portable. The laptop is meant to be mobile. We often refer to that as a notebook now instead of a laptop, because people were actually putting them on their laps, and the little grates and things in the bottom that were supposed to be circulating air so it didn't overheat got clogged up, like on people's pants legs and stuff, and they would overheat and ruin, and people got upset. So they said, let's just call it a notebook, because you know you carry a notebook around, so we'll just call it that instead. So you might hear it either way. As far as mobile devices go, SoC is system on a chip, which just means all the circuitry for it is on one chip. We'll talk about some examples of that. And in an embedded OS, there's a mobile device that stores all its OS in a firmware. And you can see this in certain mechanical applications, kind of outside of our computing world, but you might run into it. So as far as what we see in an environment today, we've got servers and we've got clients. So a server is called such because it serves up some sort of resource to one or more computers on the network. The client is the computer that uses that service. So when you all logged in here today, you were served up an account from our Active Directory server. Now that's all it does at this point. It does do some file server stuff that we'll use later on, a couple chapters down the line. But it's serving up resources to other people, hence why we call it a server. Some of the other things it can do, it can be for email, for files, for printers, or for messaging. Let's say you have an internal messaging application that the business uses. The Internet of Things is something we hear about every once in a while. So microcomputers are installed inside different kinds of devices now, and they're connected to the internet. Can anybody give me an example of something that is a smart device?
A fridge.
A fridge. Fridges now order your food for you, which is dangerous. Yes?
No, I'm just scared of that.
I'm scared of that too.
The hue lights.
Huh?
The hue lights and thermostats.
Lights, thermostats, the Nest. If you've ever heard of the Nest
Yeah.
thermostat, you can set it from your smartphone. And it can kind of intelligently try to balance so that your bill goes down. You can set home automation with lights and stuff so that they dim or turn on, turn off at different times. So yeah, there's a lot of that home automation stuff, and that kind of falls into the category of the Internet of Things. Also, utility meters and things like that that are, instead of having meters be read, they're connected to the internet so they can be processed. So there's lots of different parts to an operating system, and they all have to work together to get anything to work, much less an application. Those applications are written so that they interact with that specific part or that specific function. So here's some of the ones that we're going to talk about throughout the scope of this lesson today. The very first thing there is the user interface. So We sometimes hear this called the shell. This is the shell that the human being in front of the computer sees. You can use command line interface. If you've ever dealt with anything in Cisco, you remember what that's like. If you ever dealt with DOS, like I did, then you know what that is. So you've got a blinking cursor, you got a black screen, and doggone it, you got to know all those commands by yourself, or at least know how to get help so that you can see the list of all the commands that are available at that time. You type in commands, the command prompt responds back to you. It's really useful, but of course it's not very user-friendly because you have to know exactly what you're doing, right? There's quite a barrier to entry when you're looking at something that is command line like that. So now we use a GUI, or a graphical user interface. So everything is a picture that indicates what that thing is. So there's menus, there's icons, there's graphics, and they'll interact with the computer. So you use this pointing device like a mouse, or maybe like a pen on a tablet, or your finger on a smartphone, to select what you want to do. This is much more user-friendly because you can see, okay, if I want to take a note, I hit the thing that looks like a notebook. If I want to check my email, then I hit the thing that looks like an envelope. So it's a little bit more intuitive for somebody coming into it to be able to use. So let's talk about some of the things this GUI or this command line is actually doing. The big thing that job management does is that it controls the order in which programs run. So it prioritizes for you. So this can be with programs, it can be with something that's printed. I heard a good example the other day of, let's say the computer in your car knows that the braking system is supposed to hit before the music turns down, because the braking system has priority. That's kind of an example of what job management looks like. So that could be scheduling a process, or maybe managing different prints. If you print more than one thing at a time, instead of just getting a whole bunch of sheets that are all the different documents but in different order, you get the stuff the way that you intended to see it. Task management, it also handles multitasking, which is doing more than one thing at a time. The OS manages what processes happen and when they're supposed to happen. So it also manages things like, where is the system giving its resources right now? What is the thing that gets all the power of the computer at this point? Is it the right thing? Do we need to reallot something? Is something so resource intensive that it's going to cause the computer to crash, and maybe I should just stop it before that happens? Those are some examples of task management. It also deals with file management. So we have a file system. In order to be able to access this operating system, we have to have a file system that's going to allow us to read, write, and modify data while it's still managing all the data that's stored on the computer, like our documents and our music and stuff like that. So the file system is this logical structure that says this folder has this file in it, it has this folder in it, and it all flows and makes sense to us. Formatting is one of the things it can do. It's writing a structure so that, for instance, if you format a flash drive before you use it, you can store files to it. But you have to have something kind of in the background to be able to hold that file and know what to do with it. An SSD, does anybody have an SSD installed? A couple people? So an SSD uses integrated circuits, right, instead of these traditional hard drive platters, and it's unbelievably fast, wonderfully so. A partition is just a defined area of a hard drive. So you can have more than one on a drive. You can say, here's a 500 gig partition, and here's two 250 gig partitions, and I'm going to store different things on them. Can anybody give me an example of when you would want to partition a hard drive?
When you're installing the OS.
Huh?
When you're using the OS, and
Okay.
I would put my OS on an SSD,
Yes.
and the hard drive will be like as a backup.
Yes. And that is a very good example of using a partition. So let's say I'm going to put my OS on the SSD so it's faster, like he said, and then I'm going to just use the hard drive for storage. Another reason you could do it is you could make a 100 gig partition and install the operating system on it, and then store all your documents somewhere else. And then if, let's say, a virus gets in and eats up your operating system, you can just reinstall it and all your data's still there. That's another reason we might want to use that. And then folders and directories are things that we use to kind of group this stuff up in a way that we can read it. It also does device management. The OS needs a driver for everything that it's going to use because it has to know what it's supposed to do with it. So, for example, a printer, a Bluetooth headset, it can't use the device or can't use it fully if it doesn't really understand what it is or what it's supposed to do with it. Plug and play is something that is part of Windows. That means the operating system is smart enough to just detect what driver it's supposed to use and install it. You plug it in and then you play. There's nothing else that's involved. And it's always wonderful when that happens, although it doesn't always happen. The operating system also has to keep track of where programs and data are in memory. We have virtual memory, which is basically using the storage that's on your hard drive as though it is RAM, which can be interesting. We also have to deal with some operating system memory limits. So there are certain versions of Windows that only run about 3 or 3.5 gigs of RAM. We'll get into that, and some that run more. But it depends on how many locations there are for memory. But the operating system is what determines that. For example, in Windows 7 Home Premium, you can have 4 gigs of RAM. In fact, everything that's 32-bit in this column can have a maximum of 4 gigs of RAM. After that, if you installed more RAM in the system, Windows wouldn't see it and wouldn't use it, and that can be frustrating for people when they don't know this. Whereas a 64-bit version, it has more spaces available to write things to because it has more logical places to put stuff. So you can have, for example, a Windows 10 machine with up to 2 terabytes of RAM. That seems ridiculous to us now, but when I started using a computer, we had 128K, and it was unbelievably fast. So the speed of technology is progressing to the point that one day, within our lifetimes, we very well might see 2 terabytes of RAM being used. If you want to find out how much RAM you've got, what your type of operating system is, you can go to the System within Control Panel, and you can see in this instance it's a 64-bit operating system. And it has 8 gigs of memory installed. So that is well within the limitations of a 64-bit operating system. Another thing the operating system provides for us is security. For example, when you logged into these computers, you had to have a user account to be able to do so. What would you have done if you didn't have an account when you walked in?
Make one.
But you're on a domain, you can't do that in here.
Ask someone to make
Ask
one.
someone to make you one, right? Because that's part of the security, is being able to get that access. So you would do that with a user account. When you leave your computer, you can set it so that you need a password to get back into it. That's the way these are done. They'll time out after a while so somebody can't come in behind you and steal your work or anything like that. Okay, let's talk very briefly about the evolution of the operating system. So the very oldest operating system was called Unix. That happened in Bell Labs in 1975. Now there were years before where they had the ENIACs and the punch cards and all that stuff, and they didn't have an operating system. They had to write what was called machine language, which basically means humans have to talk in ones and zeros, right? Then we had the Unix version 6. That was what we called a portable operating system, which means it could be used on lots of different kinds of computers, and that was a really big deal back then. The University of California licensed that. They modified it, and they distributed it as what they called Berkeley Software Distribution, BSD. There were different versions of that came out, OpenBSD, FreeBSD, and people would kind of grab that operating system and they would write their own code, and they would add to it and improve it. After that, we had AIX, OpenServer. They were commercial versions of that, so people would say, hey, I'm going to take this software, I'm going to fix it, and then I'm going to resell it in some commercial capacity. So that was back in the days of the Unix. Unix was also used on servers on the internet. We had different kinds of interfaces and stuff like that, GNOME, C Shell, Bourne Shell, but Unix is still the foundation of everything that we use today. As far as the desktop operating system, well, that didn't happen quite as quickly as the other. The user was supposed to define what that computer was supposed to do, so that could just be a single task. The computer was designed to do that thing. It wasn't really until we had early operating systems that allowed us to do more than one thing at a time. So the programmers would write system code in the applications, but by the mid-60s, large computers had these hard disk systems. They actually had disks to manage, so that's when the operating system came to be. In the 70s, they had the earliest macro systems actually become. They actually were available for sale. They were really, really, really expensive. This is one of the examples used in the textbook. Because of the power of Google Books, this is the original MITS ad that was run for asking people to build your own computer, so to speak, which is not like what we think of it today. So the MITS Altair 8800 had 41 bytes of memory available. So in the 70s, that was $700. That doesn't sound like a lot, but in the 70s, $700 is a lot more than it seems like it is now. So because of these computers and being able to put them together and build them, so to speak, which really just meant to put more memory in it, there were these kind of homegrown computer enthusiasts that came to be. Well, they weren't commercially available before, so it was a really big deal to be able to have one in your home. Even if it didn't do just a whole bunch, you were just excited to have it. So that became what was known as the Homebrew Computer Club. So about that time, a software version is a unique level to an operating system. So when a new one is published, it gets a new number. So that's why we see, Windows 7, Windows 8, 8.1, as we'll talk about. Well, how do you think a new software gets published? People have to figure out what's wrong with the old one, right? So now people had these in their homes that they could say, hey, here's a bug, here's an improvement, and then new versions of that could come to be. So because these were commercially available, we started seeing versioning of operating systems. So the Apple II, there was what we call a killer app. So a killer app is an app that a lot of people need enough to purchase a computer. And for the Apple II, that was called VisiCalc, a very, very sophisticated spreadsheet, as you can see. This is VisiCalc. Google is amazing, right? So here you have black and like light turquoise blue text. This is someone's home budget. So they have used this electronic spreadsheet software to make their own budget. Well, apparently using spreadsheets at home on a computer was just mind-blowing, and everybody wanted one. So everybody ran out and bought a computer. This is a far cry from what we use in Excel now. But homes used it, businesses used it. This is why the Apple II sold so well, with just that one little piece right there. Then we had the IBM PC operating system. It had a BASIC interpreter. BASIC stands for Beginner's All-Purpose Instruction Code, and it was encoded into the read-only memory of that PC. They needed an OS, but at the time, Microsoft hadn't quite made Windows yet. So Bill Gates sent them to this place called Digital Research. They had their own OS. Fancy, right? So Digital Research couldn't come to terms with IBM on making a contract for this operating system. So Microsoft bought it, and the operating system was the basis for basically every IBM PC sold for quite a while. The sales were really, really high. The operating system was $5,000, but they sold over 500,000 units, so I'd say that's a pretty good return on investment. It had the IBM logo. The business had bought it, so it looked like it was like a commercial grade kind of thing. It had the IBM name behind it, so that ended up being introduced in 1981. The killer app for PCs, the one everybody wanted, was Lotus 123, which I just barely remember. This had a spreadsheet database, and it even had like a graphics editor, and it was super pixelated and stuff, but that was the thing that everybody said, oh, I've got to have a PC because now I have this available. So it was designed to use less memory, so it was more efficient than VisiCalc. So we already have this, my stuff is better than your stuff, everybody goes and buys it. Now the other person's better than them, and they go and buy it, and this cycle keeps continuing. That we still see today, especially with mobile devices. The Apple OS, we know that Steve Jobs and was it Steve Wozniak, right? The two Steves?
Yes.
Founded Apple Computer Company in their garage. They went to a computer fair and showed off the Apple II. And in '84, we had the Apple Macintosh computer with the Mac operating system. The Apple Lisa was the first commercially available computer with a GUI and a mouse, but there were no applications on it. Basically, everything ran off of disk, like Oregon Trail when I was in the 4th grade. It's impossible to win Oregon Trail. Do y'all remember that game? Everybody dies of dysentery.
It's been a long time. but
You can
yes.
go online and find emulators for it. It's still just as fun as it was.
It still exists?
Yeah,
Oh my
Yeah.
gosh.
yeah, impossible, but also fun. 1999, we had Mac OS 9. In 2001, they were replaced by OS 10, Roman numeral 10 for X. We had MS-DOS, that's from Microsoft Disk Operating System from 81 to the 90s. I was born sometime in there, but I'm not going to tell you when. So this was for all the computers that were not IBM computers. So this was single tasking. It was just that command prompt thing. It popped up and you had to know exactly what to do. But again, it was in our homes, so it was awesome. There was very limited memory support. There was no built-in security whatsoever. If you could go turn the computer on and sit down in front of it, then you could do just about whatever you wanted to do. Here's an example of a MS-DOS prompt that's showing the format command. And it spits out, hey, I'm going to format this drive, are you sure? And then it does it. And it's really pretty quick because there's not anything else going on. All the resources are allotted to whatever's on the screen. But you see there's no GUI. This is just command line. Again. OS 2 was made by Microsoft and IBM. I think we still have some copies of that floating around at college somewhere. 1987, they had version 1.0. Now, you see it says created for Intel 802086 processor. Think about that for a second. They made an operating system for a specific processor. How do you think that would fly today? It would not, right? Because we can install Windows, let's say 7, on almost anything, right? And it will work. So think about how small computers were compared to where they are today. Back in '87, when they could write a whole operating system for one specific piece of hardware. That's kind of fascinating to me. It required 2 megabytes of memory. Megabytes, not gigabytes, megabytes. There was command line, and it didn't support a whole lot. People had to write applications specifically for that OS 2 to work. So they had OS 2 Warp was their improved version on that. They targeted high-end servers and it ended up being pretty successful. But in 2005, IBM got out of the operating systems game. They stopped going for desktops. They started going to the high-end server market. You might make the argument that because they closed shortly after that, it didn't work out too well. That's up to you. Microsoft Windows, in the 80s we had versions 1 and 2. In the 90s we had 3.1. I'll let you read the rest of those slides. As you can see in 2000, we started out with Windows 2000. Their numbering scheme is a little unconventional, especially lately, right?
Yeah.
What happened to Windows 9, nobody knows. Again, I think right in here is where my familiarity started. So they started with adding 1, then they went by the years they did it, and now they go to words. Like XP is supposed to stand for Windows Experience. Vista, no comment. Too easy a joke. There you go. Awesome, Vista.
You see, when Arnold I asked if he wanted to upgrade to Windows 7, he responded with, "I still love Vista, baby."
Oh heavens. Ugh.
You're welcome.
Sick to my stomach a little bit after that. So there's different products within Windows editions, and they're all kind of targeted at different markets. They're not really consistent among Windows versions, so that does make it a little bit confusing. Within one version, you've got multiple editions. Some of them have more features than others. For example, Windows 7 Home would not be able to be used in this classroom because it can't communicate with a domain server. But for people that have a home PC, they probably don't have a domain server, so that's okay. Windows 7 Professional, however, will get you on a domain server, so there's a few little things there. The more features, of course, the more costly the license. There's some editions like Windows 7 Ultimate. I remember there was a Windows XP Media Center that was meant to be like something you would hook up to your TV and use for media. Didn't really go over all that well. So again, we have our versions of Microsoft Windows way back then. It looked like this. There really wasn't a bunch on it, but it was amazing. I think it had, you know, Solitaire and Minesweeper. It was incredible. So around 92, we started getting into more of the networking phase. So at that point, it was more commonplace. People would have the internet at home. I know it's hard to believe for some of you, but we didn't always have the internet. Like there's encyclopedias at my parents' house that they still look at. But anyway, in 1993, we came out with a server operating system. So before, everybody just had the same operating system and nobody thought any different. But then they thought, wait a minute, servers need to do different things than workstations do. So why don't we write something that's specifically made for servers? And that's what they did. And as you could probably tell, since we're using them in class today, wildly popular, right? Because they were exactly right. Servers need completely different things than workstations do. So throughout the years, we've improved on that a little bit. Windows 95, they went back to original program code. Windows 95 was thought to not be very secure, so it didn't stay around very long. Windows 98 was an improvement on that. They tried to upgrade all the computers with Windows 95 on them. That sounds familiar. It had a little bit more security, but it did not support NTFS. We'll talk about that in just a second. So at this point, we're more at Windows 98. It's interesting to see that, you know, everything started out very, very boxy. And then everything went all curvy, and now everything's going back boxy. So even though it evolves, it all still comes around, it seems. In 2000, we had Windows ME, Millennium Edition. It was kind of it was the Vista of its time. It kind of flopped. It was supposed to be for home PCs. Organizations didn't really take into it. There was no security, but it had some music and video and some things like that, themes that were cool for a home user, and that's really who it was targeted to, but it didn't do so well. We also had Windows 2000. We could have editions for servers. Again, we had another server operating system to use, and it kind of looked like this. Then we had Windows XP, lots of editions of that, Home, Professional, Media Center. Windows XP was all 32-bit. So that meant if you wanted to be able to use more than 4 gigs of RAM, which at that time was kind of obscene for a computer, you had to buy a special 64-bit version of XP, which not a lot of people had and not a lot of people knew about.
Miss O'Neill was telling me to keep an ear out for a phone call possibly from 7. So, yeah.
Come on. Microsoft support for Windows XP ended in April 2014. Sadly, there are lots of industries that still run on Windows XP, like the ATM industry. Still has a lot of stuff that has Windows XP on it. So here we have Windows XP. See, the corners and everything are starting to get a little bit more rounded. Things are changing. We have the Start menu. That was a welcome addition. They reorganized it and tried to make it easier to use. Then we had Windows Vista. Everybody hates it. Why does everybody hate Vista?
Was it too slow?
It was slow. This is true. It also had that thing that popped up and said, "You sure you want to do this? Are you sure you want to do this?" Are you like constantly? That was it, right? That was the killer. Nobody liked that. That's called user account control. And it's actually a pretty popular feature, or it's a powerful feature, maybe not so popular. But here we had Windows Vista. They had this kind of gadget thing over on the side they were experimenting with. There was some transparency, so it was like they upped the graphics a little bit. That was nice. So let's talk about the operating systems that we're using today. So we have Windows 7, 8, 10, OS 10, and Linux, and these are all the things that we're going to be going through in this class with a little bit more at the end. So, of course, Windows is always a Microsoft product. We've got Apple, and then we've got Linux. Linux has a lot of distributions to it, but we're just going to focus on a couple of them. I know I'm going fast, but does anybody have any questions? I just don't want to bore you all to death. Maybe sleep, but definitely not today. Windows 7 came out in October of 2009. It was faster, it was prettier, and everybody loved it, and it pretty soon became the new standard. Is anybody still using Windows 7 at home?
Have an image already.
Has everybody moved to Windows 10 already?
I was using it and.
You got XP?
They forced it like my operating system update to 10.
Yes. At some point, they just said, forget it, we're done warning you, and all the 7s went to 10s. I remember that. Also, that happened to my mom, and she called me freaking out. If you didn't know, my husband and I own an IT business. He runs it all day. I do the bookkeeping and stuff. So I get to hear about all the things that people complain about. And I very vividly remember that day when everybody came in. It was like a Monday. All the computers updated over the weekend. Everybody came in, and they were all in an uproar. I don't know where anything is. Where's all my stuff? Why did this change? You knew this was going to happen. Why didn't you warn me? I mean, you wouldn't believe. After that, we came up with Windows 8, 8.1. More security. It had this touchscreen support, which was really good if you had a touchscreen, but if you didn't have a touchscreen, it was really pretty annoying. So they ended up kind of fixing that. So it had the two GUIs within it. That's what made this interesting. So here's the start screen if you have a touchscreen. They introduced this thing called live tiles. So these tiles within these things would update things like, photos or the weather, which is, again, cool if you like that, but if you don't, they got rid of the start screen, the traditional start menu. And a lot of people got really, really upset about that. In fact, most of the people that live in Longview got upset about it because those are my customers. So the Windows 8, again, we got a flatter look. We went back to the flatter kind of look. And you see, no start menu. It's gone. It's terrible. In the summer of 2015, we got Windows 10. It's hard to believe it's already been a year since Windows 10 has been out. They gave us a start menu back after the public outcry that ensued. They introduced something called Windows Hello, which means you can use biometrics to be able to log into your computer instead of typing in a password like we've been doing for 20-something years. They used the Microsoft Edge browser to replace Internet Explorer. It's still there, but Edge kind of takes over some stuff because it's newer. They have this thing called Universal Apps, which just means the app will run on all Windows 10 systems, whether it's a smartphone or a tablet or a PC. It'll all be the same, and they also let you to have something called multiple desktops. So here's our Windows 10 desktop. Again, everything's gone flat, and we don't have transparency anymore. It's kind of funny. Apple OS X was also based on a distribution of Unix. It had a GUI. It has the command line as well. In 2001, we updated to Windows 10 10.1, and OS 10, and it upgrades every year or two. So here's what our Apple OS 10 looks like. We'll be working with that in chapter 7-ish, I believe. So Linux is named after the guy that developed it, because you better bet if I make an operating system, I'm going to name it after me. It's going to be the Hertel OS. Or AmySoft or something. That would be cool. Anyway, in 1991, this guy named Linus Benedict Torvalds created what we now know to be Linux. He used the C programming language. There's lots of different distributions of Linux. Lots of Linux is free, which makes it very attractive. It's also very, very good at managing memory and resources in the computer, so it can tend to be way faster than the Windows and the Apple stuff. And there are some GUIs and things available that kind of go over the top of it. So here's an example. There's different distributions. This one is called Red Hat. It's very popular. That lists out the directory. So this isn't really what we're used to seeing so much if we're used to Windows and seeing, you know, files and things like that with pretty little pictures and icons on it. But it does give the same amount of information. Let's talk about mobile operating systems. We have a whole chapter on mobile operating systems. I don't want to dwell on them too much, but I do want to talk about them a little bit. So the very first one is the Apple iOS. Who has an iPhone in here? Yes. Christian, do you have an iPhone?
I have an Android.
Oh, God. Just go home.
Okay.
I'm just kidding, I'm just kidding. I'm surprised, okay? So what, 4 or 5 of us have an Apple device?
I prefer the Android because it has a higher customizability.
It also gets hacked easier, but anyway. Who cares about privacy and keeping your data to yourself? Nobody.
This day and time, that's non-existent.
What you talking about?
That's true. We also have the Android phones. Who has an Android phone?
Well, you know I do
The
now.
majority, right? It's a slight majority, but it's there. That's interesting. So when we get to the mobile OS, y'all can teach me some things about Androids. Because generally when I see, they go, hey, can you tell me how to do such and such? Because you know when you're a computer person, everybody thinks you know everything about every computer that's ever been. So they, how do I do it? I'm like, ugh, get it away. Get it away. I don't know anything. I don't want to look at it. We also have the Windows Phone. Anybody got a Windows Phone? No, nobody has Windows phones. Huh?
I was saying cricket.
Cricket, okay. I thought you were going to tell me you had one of both, and
No.
I was just going to call you a liar. But,
Oh,
so yeah,
boy.
we've got smartphones from all kinds of manufacturers. The difference between these seems to be that Apple makes iPhones and only iOSs go on Apple, and then everybody else is just kind of a free-for-all, right? Whoever can use the stuff the best. We have Windows 10 Mobile we can also use for that. That's also available on tablets as well. Some of the features of mobile devices that make them, you know, mobile. The wireless network adapters and stuff built into it so you can automatically connect to Wi-Fi whenever it's near. That's nice. Really high quality color touchscreen. I have to keep this enormous case on my phone because I drop it 15 times a day. But whenever I take that off, and I remember just how beautiful the screen on these things really is. It's really nice. You've got front and back digital cameras, right? Speakers or speaker ports, rechargeable batteries, an accelerometer. That's especially cool in playing games and things like that, so that you can physically tilt the device and it will move and respond to you. As well as some of them even have solid-state drives within them. For smartphones and tablets, especially for tablets, you may have to get, if you want to use the cellular network, you have to have a different kind of device that does it. And you have to pay another bill to AT&T or Verizon to be able to get it. You can have Wi-Fi, you can have Bluetooth. Bluetooth is typically used for what we call a personal area network. So it's stuff within 33 feet of you. I always think of headsets, and I always think of the Bluetooth that's in my car. I have Microsoft Sync in my car, and it's the greatest thing ever. Unless I have a cold and then it cannot tell anything I say, and I'm screaming at it. Some other things that...
The watches are pretty cool too.
Huh?
The watches are pretty cool too.
Oh yes, the Apple Watches and stuff. I mean, I have a Fitbit on the arm and I forgot all about it. That does Bluetooth with my phone.
Yeah.
That's cool.
I've got the Google Watch.
The Google Watch.
Yeah, it's the Android equivalent of the Apple Watch.
I've not even seen those yet.
Yeah. I'll have to bring it tomorrow.
That's cool. Some other things that mobile operating systems have, well, they have support for touchscreen, obviously, and virtual keyboards you can type on. The screen rotates unless you lock it and tell it not to. They update, sometimes too much and sometimes at the most inopportune times, but they do update. They have lots of apps on them, that's nice. There's lots of security. You can set fingerprints and things like that, codes so that you have to know the specific finger swipe to be able to get into the phone. That's cool. And then data synchronization. This is my favorite part of mobile devices. We never, ever, ever should lose anything on our phone, right? All my IT people, because it should all be synced somewhere. Okay? With Apple, it's iCloud. What is it on the Android?
It's it just saves to Google.
It saves to Google.
Google.
Excellent. So,
Your company cloud stuff.
yeah.
So if you have Samsung, it's a Samsung cloud. You have,
Okay. So it's the manufacturer of the phone.
yeah, or.
Well, mine's
Okay.
Samsung, but it still saves through Google.
Yeah, you can choose both. use
I
both.
do, like, everything I do is synced through Google, so my contacts in my email are synced with my
Right, yeah.
contacts on my phone. So if my phone falls in a lake, which is, I don't know why it would fall in a lake, but if it did, I don't lose anything because all my emails are still in my Gmail account, right? So when I hear of people losing their contacts, sometimes I get frustrated.
They got that cloud storage too, though, don't they?
Yes, the iCloud and stuff like that
Yeah,
for
that's what I
cloud
use.
storage.
Yeah.
So your pictures, things like that, they always stay, your notes and things like that. So that is, to me, the best part of being so mobile and so connected, is that I don't have an excuse for losing anything. I back everything up on Google Drive, right? I don't have anything installed on my computer that a virus could come in and connect to Google Drive with. Because I do everything over the internet. Everything's on the web. Here's an example of our virtual keyboard. So if you don't have a physical keyboard hooked up, you have to have something virtual on the screen to touch and choose letters with. So that's what that is for us. Oopsie. Portrait orientation is the up and down, like you're taking a portrait. Our landscape orientation, when we turn sideways, everything kind of shifts along with it. Certain apps work better if you shift one way or the other. We have the Apple Store. Google has the Google Play Store.
Yeah.
Google
Okay.
Play.
I know things. It's cool. I know just enough. And
Just
I don't
enough to
need
be
to know
dangerous.
anymore, right?
And
So we have the place where we can go and get apps that may or may not cost money, right?
Cheaper than iPhone.
Yeah, viruses.
then,
Open source.
Take the good with bad.
Viruses. That's all I'm gonna say.
Yeah,
That's all I
pros
have to
and
say.
Christian, at least we don't have to buy space.
cons. Right, exactly. Don't have to buy space.
What?
Don't have to buy space.
Buy
Battery lasts
space.
longer.
We can put now up to a 200 gigabit SD card.
Why do I need that much storage? Everything's on the internet. Got you there. Okay.
Yeah, but still, our batteries are still better.
Look, my battery's
Charging off
broken
on
right
what,
now.
every
so
5
I'm
Well,
just
it's
gonna-
better than
The other day, my phone was on 1% for like an hour, and then I plugged it in and it jumped up to 20. I'm like, oh, something's not right.
No.
Okay,
Phones,
so
yeah, nothing.
we're gonna do the chapter 1 key terms. All of the terms are going to be the key terms in your book, okay, for the chapter. Once you complete this, put your name on it, give it to me, and go home, okay?
At least it's not a word search.
Word search.
My eyes hate that.